Okay, this video I'm making available for both my students online and on campus. If you are a student online, this is section 10.2, and if you are on campus, this is section 7.4, testing the claim about the population proportion. It's going to be very much the same for both sections. The only difference is for my students online, when you write the null hypothesis, you must put the equal sign always in the null hypothesis. So let's see how this problem works. The engineering school at a major university claims that 20% of its graduates are women. In a graduating class of 210 students, so N is 210, 46 were women. 46 is called the number of successes, and we use X for 46. Does this suggest that the school is believable? So we want to test the claim by the school. So the claim, no, it's not a mean anymore, it's a proportion now. P equals 0.20, which is 20%, and this is where the claim is. And P is not equal to 0.20. This is the alternative. If you are students in my course online, the only thing that changes is HA is called H1. So P is 0.20, which is the claim, and P is not equal to 0.20. Okay, this is a proportion test. If using the calculator, we use one prop Z test for this one. Every time you do a proportion, this is the test. And all you need to provide N and X and the value in the null hypothesis. And let me show you how that works. So you go to Stat, Tests, one prop Z test. Okay, P0, you have to enter the value from the null hypothesis. So it's 0.2. We assume the null hypothesis is true until proven otherwise. X is 46, N is 210. And now, what is the sign from the null alternative hypothesis is not equal to, and then you can hit calculate or draw. Z is 0.69. and P is 0.4902. So let me write them down. Okay, we're using the p-value method here. It's 0.4902, 4 decimal places usually. Okay, make a decision to reject or fail to reject HO, guys. What's alpha? Alpha is 0.05, and you know this is bigger than alpha, which is 0.05. So what's the decision? Fail to reject what? HO. Because when p-value is more than alpha, you fail to reject HO. When it is less than alpha, you reject HO. Interpret your decision now. How do you interpret your decision? The claim is in HO, and we could not reject HO. So we say we cannot reject the claim. If the claim is in HO, we can never say we support it. We just say we cannot reject it. So we say there is not enough evidence at the 0.05 level of significance to reject the claim by the engineering school. So does it mean that the school is believable? Yeah, probably yes, because we could not reject their claims. Oh, I'm sorry, that should have been here, but anyway, so that's step 4. It's just failed to reject HO, and that should have been step 5 here. Okay, next question. Any Boston Celtics fan on Archival knows that Shaquille O'Neal, one of the NBA's most dominant centers of the last 20 years, always had difficulties shooting free throws. Over the course of his career, his overall made free throws percentage is 53.3%. So that's what his average. During this offseason, Shaq is working with an assistant coach on his free throw technique. During the first 5 games of the next season, Shag made 26 of his 39 free throws attempts. So the 39 is N, and the number of successes, guys, the free throws, is 26. Do the results provide convincing evidence that Shag has significantly improved his free throw shooting? Carry out a significance test at alpha equals 0.05 level. You see, this is a real word problem that you can test. So HO, HA, it's a percentage, and for my students online, I'm just going to change that to HO and H1. And again, it's a PMP. So we want to check if he improved. His average percentage is 53.3%. We want to see if he's doing better. So you want to check if it is more than 0.533. And this will be less than or equal. This is for my students on campus. They know that this should be the sign. Now my students online, it will be 0.533. And again, that should be an equal sign always. And this is the claim. And again, this is the claim. And everything else is exactly the same. So let's continue from here. I'm going to go to proportion z-test. So I go to one prop z-test. 0.533 from the null hypothesis. X is 26. X is smaller than N always. N is 39. And this is greater than. And then hit calculate, guys. That's it. And we're done. So Z is 1.67. I'll write it down. That's step number 2. And the p-value, let me show it to you again. So, because I want to try those exercises when you as you watch the videos. 0.0471. Now the question is this less than alpha or more than alpha? As you can see, it's less than 5%. So what's the decision? Reject HO. And if you reject HO, what do you conclude? Our claim is in the alternative hypothesis, then we support the claim. So we say there is enough evidence at the 0.05 level of significance to what? To support the claim that Shag has significantly improved his free throw shooting. To support the claim that Shag has significantly improved his free throw shooting. All right, so that's one. Okay, let's go to the next one. Couple more and we'll be done. There's number 8. A drug manufacturer claims that fewer than 10% of its patients who take its new drug for treating Alzheimer's disease will experience nausea. So here is, let's write HO and HA. And for my students online, it's called H1. So P and P, less than 10%, they say 0.10. This is the claim. Okay, for my students on my campus, you know that this is going to be here greater than or equal to. But for students online, you just have to put what? 0.10. And this is the claim. And everything else is going to be exactly the same. So this is section 99. And this is my section on campus. That's the only difference. There are two different books. They approach it differently, but the results are the same. In a random sample of 250 patients, so N is 250, 23 experienced nausea, so X is 23. Perform a significance test at alpha equals 0.05. All right. So just go to the calculator, go to stat, tests, proportion z test, 10%, 10. X is 23, N is 250. And what is the sign that we have to choose here? It's the alternative sign, so it's less than. Let me just do a draw here for you. Okay, so the z is negative 0.42 and the p-value is 0.3366. And let me show you again how you could get it using the other way. You could just simply hit calculate. Negative 0.42 and the p-value is 0.3366. See how important the p-value is? We base all decisions based on this value right here. Okay, well, you guys agree with me this is bigger than alpha. So what's the decision? Cannot forget this. Fail to reject HO. And then conclusion. Every time you have a fail to, you have to start with there is not enough evidence at the 0.05 level of significance. Since we cannot reject HO and the claim is in H1 or HA, we cannot support the claim. So there is not enough evidence at 0.05 level of significance to support the claim that fewer, I'm gonna write it down, guys, than 10% of patients who take the new drug experience nausea. Just copy it and paste it. Next one, number 9. It was found that 821 crashes of mid-sized car equipped with airbags, 46 of the crashes resulted in hospitalization of the drivers. So you guys know that N is 821, the big number, and X is 46. Using a 0.01 level of significance, so alpha is 0.01, test the claim that the airbag hospitalization is lower than the 7.8% rate for cars with automatic safety. So that's very straightforward. So percent, we're talking about percent. Lower means less than. And change 7.8% to a decimal. That would be greater than or equal. So this is for my section on campus. This is how you write it down. For my section online, instead of HA, it's H1. And P equals 0.078. We make them too close. And here P is what? Less than 0.078. And this is where the claim is. Okay, I'm going to go to prop Z test. Let's see and show you, walk you through the steps. Stat tests. One prop Z test. We need 0.078. X is 46. N is 821. And we need less than. And hit calculate. So Z is negative 2.35. And p-value is, let me show you the p-value again, 0.0095. And you guys agree with me this is less than 0.01, which is alpha. So what's the decision? Reject HO. And what's the conclusion? There is enough evidence at the 0.01 level of significance to support the claim. Now, one last thing, and this is in particular for my students taking the course online. When you do your homework, you might be asked to verify the requirements of the test. And the requirement of the test is that NP times 1 minus P should be greater than 10. And how do you check this requirement? Well, you already have N, which is 821. P, you pick the value from the null hypothesis, 0.078, and 1 minus P. And if you get a number greater than 10, then you can go ahead and perform the test. But when I ask you to perform the test, that means this requirement is satisfied. And for my students on campus, we check it this way. We check if MP is greater than 5 and NQ is greater than 5. Now, what is P and what is Q? Same thing. N is 821 and P is 0.078. So you multiply the two numbers. If you get more than 5, then you're good. You check it. Q is the complement of P. Q is 1 minus P. So if P is 0.07, you do 1 minus 0.078 and then multiply it by N, which is 81, and verify that is greater than 5. If you cannot verify this, or if one of them failed, that means you cannot proceed the test. But when I ask you to perform the test, I'm assuming that they are verified. But in the homework, you might be asked to verify those things. That ends testing the proportion.